A charge positive Q is in the uniform electric field between two parallel charge plates. Initially, the charge is stationary and close to the positive plate. The charge has electric potential energy. Click on the charge and observe what happens to the charge. Click on 1000 volt in the table to observe the velocity v of the charge as it emerges from the negative plate. Reset and increase the voltage V to 2000 volt, 3000 volt and 4000 volt. Describe the motion of the positive charge and the change in its final velocity when the voltage between positive and negative plates is increased. Answer: the positive charge is accelerated by the electric field. Its final velocity increases when the accelerating voltage is increased. The velocity v of a particle of mass m and charge q after being accelerated by a voltage v is calculated using gain in kinetic energy equals loss in electric potential energy half mv square equals qv. Click the velocity button to view the calculation of the velocity v of an electron after being accelerated by a voltage of 2000 volt. Click on the negatively charged oil drop, which is between two parallel conducting horizontal plates. What happens to the oil drop? Answer: the oil drop falls because of its weight, W. Drag the slider to field strength E to 2 times 10 to the power of 4 volts per meter and observe the oil drop. Then drag the slider to increase the electric field strength E between the plates to 4 times 10 to the power of 4 volts per meter and observe the oil drop. What happens to the oil drop? Answer: the oil drop remains stationary because the force due to the electric field equals the weight of the oil drop. Drag the slider to increase the electric field of field strength E to 6 times 10 to the power of 4 volts per meter between the plates. What happens to the oil drop? Answer: the oil drop accelerates because the force due to the electric field is greater than the weight of the oil drop. Click the velocity button selector to shoot the electron into an electric field. The initial motion of the electron is perpendicular to the electric field. Observe and describe the trajectory of the electron in the electric field. Answer: the path of the electron is a parabola. Click the velocity button selector again to increase the velocity of the electron. Explain the change in the motion of the electron. Answer: the deflection of the electron by the electric field is reduced. When the speed of the electron increases, the time taken by the electron to travel through the electric field decreases. Click the next button. Click the electric field E selector button and observe how the deflection of the electron is affected by the strength of the electric field. What can you deduce about the effect of the electric field strength on the deflection of the electron? Drag the correct path of each of the charged particles into the electric field. Summary. When a particle of charge Q is accelerated through a voltage V, gain in kinetic energy equals loss in electrical potential energy, half mv squared equals qv. Velocity of v equals to the square root of 2qv over m, where m is the mass of the particle. A charged oil drop stays stationary in a vertical electric field when the electric force acting on it equals the weight of the oil drop. An electron entering a uniform electric field at right angles travels in a parabolic path. The deflection of the electron depends on the velocity of the electron and the electric field strength.